defined as mass per unit volume. All right, so this would be the density. Then you have a rectangular block, and within this, it says a student measures the mass of the rectangular block and then site XYZ measured MXYZ. Very good. Determine the density of the block. Right. So you have the mass. You got to find the density, which is mass per volume. So basically, density will be mass over x times y times z. So that would be the real equation, basically. And from here, I think, and do not simplify the equation when you have uncertainty. Just keep it this way. Okay. So mass is going to be 0.243 kg. X is 5.41 times. This is in centimeters. That's not fair. I think we should. I don't know if they're asking us in meter. They are asking us in meters. So we're gonna change this. So for this one, I'm gonna write divided by 100. 0.0541 into. In fact, let's do it quickly. 0.541 times 11.09 times 1.62. And then what you got to do is that you got to multiply 10 raised to power minus 6. Now, why you have to multiply 10 raised to minus 6 is because you're basically had to convert it. Each one gets divided by 10 raised to power 2. So you can, there are three values being multiplied. So you can do this or manually do this. It's okay. So now the density that you're going to get is going to be somewhat like 0.243 divided by 5.41 times 11.09 times 1.62, and then multiplied by 10 raised to power minus 6. So this is going to be 2500 kg per meter cube. The only reason I did this is because 1 centimeter equals 10 raised to power minus 2 meter. So if I'm basically converting centimeter cube, you have to cube it. So 1 centimeter cube is 10 raised to minus 6 meter cube. So either you can remember this or individually do that. It's all right. So I'm going to write this. And please remember the answers must be to the correct significant figures. Like you see, every value that we took was actually 3 significant figures. And there's no way we can do it 3. So 2500 is fine. We're going to keep on taking 3 significant figures in the long run. All right. Now we are going to see the percentage uncertainty. You see, this is where I said keep this formula because this formula comes handy at this point. So I'm going to copy this and I'm going to put here. And I'll show you why this is important to write. So if I want to find percentage uncertainty in density, I'll simply write change in uncertainty in density over density equals to delta m over m. Just keep on multiplying every quantity and add it. Delta x over x plus delta y over y plus delta z over z. Write it differently, okay? So you do this, there's no power, so you don't have to multiply anything. And now we just need percentage. So we're not even going to solve this. For percentage, you're just going to multiply this whole thing with 100%. And then you're going to multiply this whole thing with 100%. It will convert it to percentage automatically, right? So we're going to do this. And we're going to say, all right, if this is delta m, so 0.001, 0.001, no need to change any units. 0. Because whatever the units will be on the top will be at the bottom, even 10 raised to power, so it just cancels out, doesn't matter. Then x 0.001, 5 0.001, 5.41 plus 0.01, 11, 0.01, 11,009. And then this is going to be 0.001 and what was that? 1.62. Please go download the book, okay, from your exams. Hurry up. Okay, so now percentage uncertainty is going to be very carefully just add everything in the calculator. If I were you, I just use this function 0.243 plus 0.01 divided by 5.41 plus 0.01 uh, 0.01 divided by 11.09 plus 0.01 and 1.62 multiplied by 100. So this is going to be about 1.30. So 1.30% should be the answer for this one. Then comes the true value of density of the glass is different from the answer because of systematic error. Suggest one cause of the systematic error. And obviously you're using, I think you're measuring this with something. I don't know what you're measuring this with. So you're measuring this with, I don't know what, but it could be the zero error, right? Could be the zero error, could be the error in the mass as well. That does make some sense. So yeah, there could be a couple of things wrong with this. Uh, all right. So in my opinion, I think the biggest problem could have been the zero error. You can write anything. It's all right. So you can say there was zero error, and that was in measuring the length. You can alternatively, you could also say zero error um, in pan balance because that could go wrong as well, all right? Not always the book calipers or anything like that. Now, this is it. Then let's move forward. We have linear momentum. For linear momentum, it's very easy. It's the product of mass and velocity. This is what linear momentum is. Finally, we are going to go here, calculate the maximum speed of the car. Now, how do we do this? Maximum speed of the car. So mass of the car is given. You have the maximum momentum right here. I think at maximum momentum, you should have the maximum speed, to be very honest now. So I think momentum is mass into velocity. This is going to be 7.2. So 7.2 into 10 raised to power 4, and then equals to 1800 times the velocity. I think that makes a little bit sense. So let's divide it. 7.2 into 10 raised to power 4 and divided by 1800. So it's going to be 40 meters per second. So please remember maximum velocity at maximum momentum. So then calculate the maximum kinetic energy of the car. So about maximum kinetic energy of the car, you have the speed, so half mv squared. So half times 1800 times v squared. So that could be 0.5 times 1800 times 40 squared, which is going to be 144000. You can write it as 1.4 into 10 raised to power 10 raised to power 5 joules. Now I did take it in two significant figures because everything else is in two significant figures, and I want to carry that. All right, so please remember that. That's important. Then, my buddies, okay. Then we have the next, which is the show that the acceleration of car is this. Now, for acceleration, basically, force is change in momentum over change in time, right? So for that, we need to actually find the force. And I think if you look at the steepness of this line, that is less than this line. So I think from 8 to 12, the momentum is changing more sharply. But I don't know, they're saying at time t equals to 0 is 5. T equals 4. Okay, they're saying at 4. All right, that's fine then. So, not an issue because it's just a straight line. We're going to take anything on the straight line is the same gradient actually. You can take 7.2 and 8. So, I'm going to use 7.2 minus 0. Sorry, 7.2 times 10 raised to power, it was something. 4 minus 0 divided by 8 minus 0. And then you can actually, this is the gradient, which is actually equal to force, because this is change in momentum over change in time. Okay. So you do this 7.2 into 10 raised to power 4 and then divide by 8. So this is 9,000 is the resultant force, and it is then going to be equal to ma. So mass acceleration will be 9,000 divided by 1800. So that's the mass, which I think is 5.0 meters per second square shown. So just need to remember that why I took 8 in this. I could take 4 and the value for 4, but then I have to do additional um, effort on this. I don't want to do that. What you can do is from 8, it's remember that gradient of a straight line at any point is same. So take 4, 8, doesn't matter. Then determine the distance traveled by the car. So from T0 to T12. So 12 is the end line, right? But the point is, what does the area under the graph give us? Momentum into time. Momentum into time is mass times, I don't know what it gives. But I think if this one's the only thing that we need to think, actually, it's a bit, the way I'm thinking, it can go a bit longer. But why? Why would it be? I have the maximum speed. I have everything. Then why would it be? Okay, I think let's not waste time in thinking too much. We can simply find their constant accelerations. So if I use my idea about this is basically 10 4 seconds, right? I can find acceleration and then basically I can use any equation of motion to do it. So let's try to find acceleration. So from 8 to 12 seconds, I'm gonna say acceleration was, what we found was basically from the upper part, the gradient I took and divided by the mass, right? Because gradient was that. Now the gradient from this part is 7.2 divided by 4. So 7.2 into 10 raised to 4 divided by 4 divided by 1800. So let's try this. Quickly we can find the acceleration. And divide by 4 and then divide by 1800. So it was 10 meters per second square in the first part. So we can now find the values. So here for 8 seconds, we're going to use S SUVAT actually, half into, in fact, let's use 2as equals to v square minus u square. So acceleration was 5 initially, and then you had the displacement is what we need. This is for the first part. Equals to final velocity was 40. I remember they have this was 40. 40 square minus initial velocity was 0 square, right? So S1, the displacement should be something like 40 square divided by 5 divided by 2, and that's going to be 160 meters. And I think there will be some easier methods as well. Now finding for the other part, right? So this was for 0 to 8, and now I'm going to find from 8 to 12, right? For this one, you just need to use 2. The acceleration was basically negative 10 because it was the other gradient. S2, this will 0 square minus 40 square. So let's try that now. Minus 40 square divided by 2 and divided by minus 10. So I think it's going to be 80. And the total distance is going to be total distance S1 plus S2, which is going to be 240 meters. So that should be the answer, actually. I'm sure there must be some better ways of doing this, but I don't know. With time, we'll learn. Okay. So then it says you have the variation. So that's good because now we can simply do this. We had constant acceleration, right? For 8 seconds, we had 5 constant acceleration. So, and it was positive, right? So for 8 seconds, I'm going to go straight line. Uh-oh. Straight line from 5 to 8 like this. And then draw a dotted line. Go to 10. And then became negative for the next 4 seconds. So the answer should be like this. It's pretty simple, very basic. I didn't expect them to give you that basic graph, but I think this paper is relatively very easy. All right, so pretty good. Now let's go to the next. If you have any questions, do let me know. Okay. Then state what is meant by work done by force. Work is done when you could actually write that when work is done when force is applied, sorry, when an object moves a displacement in the direction of force applied. So this is work is done. So you can actually write it if you want to. Then it says a massive block is raised vertically at constant speed. Okay. And vertical height gained by the block is change in height. Derive an expression in terms of height for the change in gravitational potential energy, meaning any symbol you use. Okay. So work is equal to force times displacement, as you guys know from the above equation altogether. Then a moment, please. I need to put the charger. Where is my charger? Hmm, very important. Okay, found it. So the thing is that work is this, and then basically F has to be mg because that's the weight you're working against, right? So, and the height S is delta H, so you can put work done as mg delta H, which is equal to change in elastic potential energy. Sorry, gravitational potential energy. My bad. Now, this side you need to identify any symbol you use. So, F we're gonna say is the weight, M mass. Or they've given in terms mass is already given. These two given. G is gravitational field strength. And what else we got? Delta H, everything else they've already given. So that's pretty good. Then says electric motor is an input power of 900 watt. The motor takes 1 minute to lift the load of weight 240 newtons at constant speed, right? Pretty awesome. And now through a vertical height of 150, resistive forces are negligible. Okay. So show that the work done by the motor in 1 minute is this. So work done again, force times. Wait, that's not fair. We have to find work done, power into time, huh? So 900 into 1 minute. So input power, the work done by the motor. So I have to use input power and 60 seconds. So let's try that. I think it should give us the right answer, in my opinion. Yeah, it does actually. 54,000. It doesn't actually. Work done by the motor. So we have to do the MGH actually. Sorry about that. I found the other one. So mass is going to be, weight is 240, height is 150. So 240 into 150 is 36,000, which is going to be 36 kilojoules shown. Then in the next part, they say useful output power. Determine the useful output power of motor. Okay. So power output is energy developed over time. So 36,000 divided by 60 seconds is going to be, I think so, 600 watt should be the output power. Keep the significant, please, and use your answer to efficiency. Efficiency in percentage. They're not asking about percentage, so we're just going to write normal efficiency. Output over the input multiplied by 100%. Sorry, no 100%. So 600 divided by 900 was the input. This is the input from the motor to the motor. So 600 divided by 900, that's not fair, is 0.67, right? So keep two significant figures, please, because everything else is in two significant figures. Some power is wasted in the motor by dissipating by the resistance of coil. The power dissipated, this power dissipated is 280. The coil of the motor is made from wire of total length 23 meters and cross-sectional area this, and resistivity. Calculate the current in the coil. Oh my goodness. I think we can do this. Resistance is rho L upon A, and resistivity is 1.7 times 10 raised to minus 8. Check if everything is in SI unit. It is actually. 23 divided by 2.6 into 10 raised to minus 8. And 1.7 times minus 8 multiplied by 23 divided by 2.6 into 10 raised to power minus 8, which is going to be 15.038 ohms, right? So this is our resistance. And we want to find the current because we have the power. We can find power equals to I square and R because we don't have the potential difference, right? So power is 280 divided by 15.04. Let's do it. divide, 15.04 equals I square. So I'm going to root it and quickly do this then, because everything feels easy then. So 280 divided by 15.04, which comes out to be 4.3 ampere. All right, this wasn't that bad. I mean, this was pretty easy. All right, if you guys have any questions, do let me know. All right. Now let's go to the next, Young's modulus. So for Young modulus is the ratio of stress over the strain. By the way, the examiner is so lenient in this. Even if you write like stress over strain and write nothing else, he would understand. But be careful about using very short terms, because sometimes there's certain words that are keywords, and I will highlight in case something happens like that. So obeys Hooke's law, stretch within this. So what's happening? So it should be a straight line, and it must pass through the origin. What is my line doing? Okay, it should be a straight line passing through the origin, no curve, because it is within the limit of proportionality. Okay. Then it says name the quantity represented by the gradient. It has to be the spring constant. And then it says state the name of quantity represented by the area under the graph. It is going to be the elastic potential energy. By the way, elastic potential energy has other name as the strain energy. Okay, so whatever you like, right? It's okay. Then says another wire Q is made from metal has twice the Young modulus of metal P. Okay, and wire Q has same volume as P. Understood? Same volume, huh? And then it says that but the double the cross-sectional area of P. Double cross-sectional area. Interesting. The two wires are extended by equal tensile forces within the limit of proportionality. State and explain how the extension of Q compares with P. Okay, now this is something very, very interesting. Every time I'm just going to tell you, this is the biggest keyword you will find, same volume. I'll tell you why. Actually, the real formula that we will always follow is obviously E equals to FL over AX. But you might notice that there's area and there's no volume, but they've not told us about the length. So don't assume the length is the same. Okay. And what they're looking for extension. So I'm going to bring extension here. I'm going to bring E here. Now think about it this way. Volume itself is area times the length, as you guys know, right? If the volume is same, now this is a constant, and you want to keep it constant, right? So if you double the cross-sectional area, you have to half the length to balance the equation. Do you guys understand this? Again, double the area, as it says, then the length is going to be halved because volume needs to stay the same. That's why. So if you check the extension, what's happening? Force is same, length is halved, area is doubled, right? And Young modulus is also doubled, right? So I'm just going to multiply 2. And then if you notice, the factors, whatever factors you use to multiply here, multiply on this side as well. Half, and then in the denominator, 2 and 2. So you might see the new extension is going to be equal to, the new extension will be equal to 1 over 8 of the old one. So this is basically the answer for this question, right? So we're going to say, so you're going to show this to them, right? So we are going to say, we have also shown the proportionality. Just do this and write that the new extension is 1/8 of extension in B. Now that's all you need to do. Show the ratio, what you're going to use, show how you used it, and then that's it. So 3 marks for literally nothing. All right. So very good. Now let's go to the next. In the next one, it says potassium undergoes beta negative decay to form a nuclide of element X. Particle Z is emitted during the decay, and the equation is shown. So what is PQRS? First of all, you're gonna use this. So this is beta negative. R has to be 0, S has to be -1, and this is going to be by the way, it's going to be 40 because in beta decay mass doesn't change, but this is going to be 20 because it increases a bit. So and you can try this as like 19 equals to Q minus 1. Okay, so now name the particle Z. So every time there is a lepton release, with it an anti-lepton is released, and the anti-lepton in this one has to be the anti-neutrino, electron neutrino. Basically, you can write that, but it's all right. Whatever you write, doesn't matter. So anti-neutrino, and then state the name of the fundamental particle both beta and Z belong. So they are basically leptons, and then determine the core combination of alpha particle. So alpha particle, what? Okay, no worries. Alpha particle is 4 and 2. So it has 2 protons and 2 neutrons. So proton essentially is just up, up and down. So multiplied by 2 plus 2, and this is up, down, down. So what would be the composition then? Let me see, right? So we have, in this one, we'll have 4u plus 2d, and this one we'll have 2u plus 4d. So that's going to be 6u and 6d's. So the core composition is 6 up and 6 down. So this has to be the core composition. Pretty sick. All right, let's go to next. Then two coherent sources X and Y of microwave frequency are distance 18. Okay, so they are coherent. This is a classic double slit. So every time I see double slit, I only remember one formula: AX equals lambda. All right, so let's try this. So there are phase difference of 90 degrees between the waves emitted. Oh my goodness, something new has come up. The microwave detector moves along PQ, which is parallel joining two forces, joining the two sources, and 23 away from it. What? Okay. Point O is on the axis PQ at the position and equidistant from two sources. And point A is the position on line PQ where intensity of microwave is the greatest. Explain why the position intensity is not at point O. The reason why usually you see the maximum intensity or the brightest spot or highest displacement or loudest sound at O. So at O, because they are the path difference from here and here is same, unless obviously the phase difference is a bit different here, right? So that's why we can say that. All right. So we're going to say for maximum, maxima at the center, for maxima at the center, so for maxima at the center, we're going to say that the sources must be in phase. In phase basically means 0 degrees or 360, right? At O. So that's the point of it. But here, we're going to say that since two sources are at 0 degrees, at 90 degrees, So greatest intensity not at 0. Now draw a cross to show the position of point P with the intensity minimum that is closest to point A. Label this point P. Okay, that's interesting. How do we do that? Very good. I think the point A is the maximum intensity. So I think there has to be a point B where and what is O actually? It is equidistant. Hmm. We have to think actually. This is tricky, huh? I think if this isn't the minimum, so if I think about it this way, that this is the maximum intensity, the minimum should come here and then maximum and then minimum. So I think it should be somewhere on this side. So I'm going to take it as B, and that should be the distance or the point they want us to find. So this is something I would basically prefer. And with respect to the center, the distance from A and B should be almost equal. So that's important. Then it says, show that the wavelength of microwave is 0.12. We're just going to use V is equal to F lambda. And the frequency is this. I don't know if the speed, what is this? Microwaves. Very good. So 3.0 and 10 is per 8. And 2.5 into 10 is to 10 times lambda. So now see 3.0 into 10 raised to power 8 divided by 2.5 into 10 raised to power 10. So 1 point, oh my goodness, I made a mistake. Sorry, I had to, the board mass mistake. This will be the answer, 0.012 shown. Then for a point A on the line PQ, determine the difference in distances x traveled by microwave and y. So we have to find the difference from here and here. Interesting, huh? So for that, I think it is pretty simple, not a big deal. You see, the difference is of 90 degree, right? So you know that 0.012 meters is equivalent to 360 degrees phase difference. So how much difference would be in 90 degrees? So this is what I'm going to do. I'm going to cross multiply. And when I do that, it's going to be 0.012 times 90 divided by 360, which is 0.012 times 90 divided by 360. And that is 0.0030. So that should be the answer actually. Then using the formula for double slit interference of light, calculate distance between adjacent maxima PQ. What is PQ? P adjacent maxima on PQ. So basically we want to find X, right? So AX equals lambda D, like I told you. And we got to find that X. So lambda D over A, lambda is 0.012. The distance is given as 2.3. And A is given as 0.18. That's the difference, right? 0.18. So 0.02, 0.012 times 2.3 and divide by 0.18. So it's going to be 0.15 actually. So this should be the answer. So yeah, pretty good. Pretty good. Right. All right. So we're done here. Finally, we moving towards the last question, which is this one. And it says two resistor connected in series. EMF is given. Okay, one has this, and you have the terminal potential is 1.6, which means both of them are getting 1.36 volts. This is terminal potential. Show that the current is this. All right. How do I find the current? That's not fair. I think we can find the current. It's not a big deal because the EMF is equal to terminal potential plus the voltage lost. Voltage lost will be equal to 1.50 minus 1.36. 0.14 volts, and voltage lost is basically I times small r, the internal resistance. So 0.14 divided by 0.28 is actually 0.50 ampere. That's how we're going to show it. So pretty good. Then it says calculate the combined resistance of the two resistors. We have the resistance, we have the current passing through a series circuit, so it's okay. V is equal to IR. This time we're going to use the terminal voltage. Current is this, so I think it's going to be 1.36. So it's 2.72. Pretty awesome. Now, my buddies, then it says use your answer to determine R. What kind of question this is? This is like O levels, literally O levels. So 2.72, because that's in series, so 1.0 plus R. So it's going to be, I think, 1.72. Oh my goodness. What type of question? I think they just gave a filler question. They were thinking maybe, what do we do? Let's give the easiest question ever. So complete the diagram, show this arrangement. What arrangement? The circuit disconnected and two resistors connected to the cell and now parallel to each. Oh my goodness. What is this? Just make the arrangement, please. Let's copy this. The first one is 1.0 ohms, and the other one is, what did we find? 1.72, like that. Then says without any calculation whether terminal potential difference across the cell is now less, equal, and greater. I think I know the answer to this. I know. Basically, you guys need to understand that resistance, which I'm talking about the load resistance that is outside, decreases when added in parallel, right? So if the resistance decreases, current increases in the battery. Or you could write circuit if you want to. Then what happens is, hence, voltage lost, which is equal to I equals to IR, increases. So terminal potential decreases. So this is a classic question, comes a lot of times, and you can check it out, please. So yeah, this is the end of the chapter then. End of the first exam. If you have any questions, let me know, please. Now it's very essential, my kids, that you solve the